Hello everyone. In the last video, we studied about the exercise 10.7. Now the next question is exercise 10.8, which is what are the ambident nucleophiles? Give examples. So let us take this question now. So this is the question that what are ambident nucleophiles? Explain with an example. So ambident nucleophiles are the nucleophiles that can attack or that have two different attacking sites through which it can attack the electrophile, and they can form two different products. So the example, one classic example is cyanide ion Cn negative. I'll explain you through the reactions that how it is an ambident nucleophile, how it reacts through the carbon atom and through nitrogen atom to form two different products. Uh, so let me take the first reaction in which the carbon atom is the attacking side. So let us take R, Br. This is bromoalkane plus the reactant KCN. So here the cyanide ion Cn negative has two attacking sites, that is carbon and nitrogen. So the first case, we are reacting it through carbon atom. So the solvent will be here acetone. It is polar aprotic solvent. So through this solvent, the nucleophile, this ambident nucleophile, will react through the carbon atom, and your product will be RCN plus KBr, right? So this is the ambident nucleophile CN negative. And here the attacking side is carbon atom. So the product is RCN or alkyl cyanide. Um, Now, if the reacting site is nitrogen atom, so the reaction will be as follows: bromoalkane plus KCN. Here we are taking solvent polar protic solvent, that is ethanol. So the reacting site will change. It will become nitrogen atom. So the product will be different. So the product will be RNC. This is what? This is isocyanide, alkyl isocyanide, or it is also called as carbalamine. And the previous product was called as cyanide, or alkyl cyanide, or it can be called as nitrile also, right? And KBr is the side product. So you can see that this cyanide is an ambident nucleophile. Why? Because it can react through the carbon side or also through nitrogen side. And when it reacts with two different sides, it forms two different products due to just changing the solvent, right? We can take another example also. Similarly, another example is NO2 negative. NO2 negative, that is nitrite ion. Okay, here the example was Cn negative ion. um, it also have two attacking site. One is nitrogen and another one is oxygen, right? So let us react the first, that is bromoalkane, with KNO2. So the product will be here, the reactant is KNO2. So now the product will be, the first product will be what? O N O. So what is this? This here, the the oxygen atom is the uh, attacking atom, right? So this product is alkyl nitrite, right? And the side product is KBr. Similarly, if another reagent is here AgNO2, silver nitrite. So the attacking atom will be nitrogen here. So you will get nitrogen oxide, alkyl nitrogen dioxide. Okay, RNO2. And the side product will be AgBr. So you can see that how this nitrite ion have two different types of attacking sites. One is nitrogen, second one is oxygen. When oxygen is acting as the attacking site, then the product is alkyl nitrite, right? And when nitrogen atom is the attacking site, the product is alkane nitrogen dioxide. Okay. Similarly, let us discuss one more example. There are many examples, but let us discuss one more example. So the next example is HCN negative ion, or you can say thiocyanate. Thiocyanate ion. This is also ambident nucleophile. Why? It can act through two different sites, nucleophilic sites, that is sulfur and nitrogen. So first we'll take the attacking side as sulfur. So what will be the product? We are taking KSCN. Okay. So the product will be alkane, alkyl thiocyanate. So the alkyl group with the sulfur group will attach to the alkyl group. So here is the product. Uh, and if we take another uh, site, that is nitrogen site, then what will be the product? The product will be thiocyanate, because the reacting site will be now nitrogen. The reacting site is here, nitrogen. So you can see that this is HCN. Thiocyanate ion is also an ambident nucleophile. So what is the conclusion? That ambident nucleophiles are those nucleophiles which has two different attacking sites, through which it attacks on electrophiles and make different products, right? And we have studied what examples? SCN negative, thiocyanate ion, nitrite ion, NO2 negative, and first example was cyanide ion, that is CN negative. Okay, so I hope you have understood this topic. Thank you.